Hey, it's Mr. Engstrom here. Here's what I want you to do. I want you to think of a random two-digit number where both digits are different and both digits are odd. Did I get it right? Maybe not. But a lot of people pick 37. You see, we didn't need to. We could pick 93, 75. If it really was random, then all of those would have an equal chance of being selected. But the problem is when people select something, it's not really random. There's going to be some sort of a bias. Biased simply means that some responses have a higher probability than others. Another place we see it, if we want to do a survey and try to find the average height of an American, we wouldn't take a random survey of professional basketball players. That would be biased. So the purpose of using randomization, random selection, is to reduce bias. So let's look at some methods of randomization. We could use a random number table. Simply put, it's a table of random numbers. How can they be random if they're already on a paper? If you take a look at page A23, it's in the appendices in the back of your book. It's used a random number generator, generated a bunch of random numbers, and put them on the paper. So we could use those as random numbers. Or a calculator. The rand int 1, 100 means you're going to randomly select an integer from 1 to 100. Look at the second one, rand int 1, 100, 10. Of course, that just means that we're picking 10 random integers from 1 to 100, and we call that pseudo-random. The reason why we call it pseudo-random is because the calculator has to do something to get that number. There has to be an algorithm that's in the calculator, which is why we had to seed our calculators over the summer. Okay, online random generators, all kinds of them. There's one, a good one at random.org. If you look that up, you can use that online. We could pull slips of paper out of a hat. We could put beans in a bag and shake it up and randomly select. We could use cards or dice, which is actually pretty common. However, we got to be careful there. Probabilities need to match. The probabilities need to match. Here's what I mean by that. If you roll 2 dice and get the sum, you add up the number on top of both dice. The probability that you roll a 7 is higher than you roll a probability of a 2, simply because there's more ways out of the total population of 36 outcomes, 6 times 6. There's more ways to get a 7. You can get a 3 on the first and a 4 on the second, a 4 on the first, a 3 on the second. You could get a 2, 5, 5, 2, 6, 1, 1, 6, right? There's lots of different ways, and there's only one way to get a 2, a 1 on the first and a 1 on the second. So the probability that you get a 2 is much lower than the probability that you need that you roll a 7. So you need to be real careful with the using cards or dice. The probabilities need to match there. Using cards, if you draw 2 cards, the probability that you get a king on the first card is different than the probability that you get a king on the second card. You see, if you take two cards out, 2 cards randomly selected out of a deck, that second card really depends on what you got the first card. If the first card is a king, the probability that you get a king on the second one isn't 1 out of 4 kings because you've already used a king up. Probability that you get a king on the first one is 1 out of 4, 1/4. The probability that you get a king on the second is not 1/4, it's 1/3 because you only have 3 kings. So you've got to be careful. The probabilities need to match. So be careful with that. Make sure you do the reading tonight, get those notes done, and I'll see you tomorrow.